Okay, so the final three applications of all this polynomials work. They're all beautiful, you're going to love them. Okay, so say I know what the picture looks like, and I want to go backwards to get the equation. Now, I've been told that it looks like this. Some number, x plus something all squared. This could, of course, be negative. X plus something else. And I'm trying to figure out what is k, what is a, and what is b. It's actually really easy. It's really easy because what do we know about these two things here? These are called solutions or roots. What it says is that when x equals 2, y equals 0. It's the coordinates 0, 2. Okay? Sorry, the coordinates 2 on x and 0 on y. So what that means is this y answer is going to have to be 0 when x is 2. And how can that possibly happen? Well, it can only happen if one of these two, a or b, is a negative 2. Okay? As we know, having a bracket like this, x take away 2, will give me the solution x equals 2, which is what I want. The other bracket is going to have to be giving me this solution, x equals negative 1, so that'll be x plus 1. Only question, which one of these is going to be the one with the squared? Now you can probably have a lucky guess. Which one of these looks like a very special solution? Well, it's this one. This one is what we call two repeated roots or two identical roots in one place. Okay, so this one happens twice. You get the just touching bouncing thing going on when you've got squared, when you've got two identical roots. So basically, this one is going to be squared. And what does that mean? A is going to equal 1 because x plus 1 gives me this answer here twice for the bouncing. B is going to equal negative 2. And you can just write this down. The question will just say write down probably. K is then slightly more fun. Well, I've used these information. This bit of information is the last one. Okay. So what do I know? That when x is negative 3, y is 10. So I'm just going to actually have to put these into my function to work it out. Y is going to be 10 when x is going to be negative 3. I also know what a is, right? So it's plus 1 squared. And here I've got x is negative 3 and b is negative 2. So I've put in the a and b that I know. I've put in the x, okay, from this coordinate here, and that's going to give me y for the answer here. So now I just have to work it out, okay? So I've got 10 is k, negative 3 plus 1 is negative 2 squared, negative 3 take away 2 is going to be like negative 5. Negative 2 squared is 4, positive 4. 4 times negative 5 is negative 20, so 10 is negative 20k. Divide by the negative 20, and I'm going to end up with 10 over negative 20 equals k, which can more easily be written, cancel these out, as minus a half equals k. So there we go. We can work out what these are going to have to be by looking straight away at the solutions. They're obviously the ones in the brackets. We know how that works, but kind of backwards. So negative 1 there gives me x plus 1. And then sub in everything I know with these information here to find out what the last unknown letter is going to be. Okay, second fun application. Prove that this function is always positive. You might think it might be because it's plus a big thing. This is times by x, so I don't know if x is like 5, this is negative 30, so we'll find out, okay? How are you going to do it? Well, the exam would almost certainly give you a hint. It would almost certainly have a part A that says, write it in the form like this, i.e. complete the square. How do we complete the square? Well, the easy way, if you're not quite sure, is just work out what this is going to be. Expand these brackets out, x plus p squared plus q, expand these brackets, and I've got x squared plus px, so plus 2px plus p squared plus q. And then I just have to compare these coefficients with these ones, okay? The x squared already matches, negative 6x, 2px. So basically, negative 6 is going to have to equal 2p, and p is going to be negative 3. And then at the end, I've got p squared plus q, the numbery bits, matches 39. So if I've got p squared plus q is 39, and p is negative 3, negative 3 squared plus q is 39, 3 squared is 9, so 9 plus q is 39, positive, notice, and that means that q is going to equal 30, okay? So I can now write this in this form. How am I going to do that? Just write it down. X squared minus 6x plus 39 equals x plus p is negative 3, so x take away 3 squared plus q is 30 plus 30. Okay, so what's going to happen now? I'm going to have to try and work out whether this is always positive. Well, here's how I answer the question. Here's how I prove that it is always positive. Okay, so first point, anything squared is greater than 0. Okay. Second point, therefore, x minus 3 squared plus 30. Well, actually, that's greater than or equal to 0, technically. It could, 0 squared is 0, so it could equal 0. This is now definitely greater than 0. So, therefore, always positive. Okay? So, what have I done? How do I show something is always positive or always negative? You'll write it in the completed the square form, and then you'll be able to straight away see, right, whatever number this is, positive, negative, anything, right, square that number and you're going to get 0 or bigger. Add 30 and suddenly you're going to get something that's always positive. So there we go. Right, finally, for what values of x is y equals this thing greater than 0? So this is going to be much more fun. Okay, it's not always positive, it's only sometimes positive, and we're going to figure out when. What x numbers in here make the answer be greater than 0? So, how do I do it? Basically, we're looking to solve it. We're looking to sketch it, to understand it, to put together all the learning we've done so far. So, easy way to solve it is to factorise. Let's try and get two brackets. X squared, so an x and an x. Negative 7 is going to be a minus 7 and a plus 1 to give me the negative 6 there. What does this mean? The solutions are x equals negative 1 and x equals 7. So here we go, here's 7, here's negative 1. It's a positive x squared graph, so happy positive shape. There we go. Now the question didn't ask me to find the solutions, but I've got most of the marks already. What did the question ask me to do? Is it asked me to say, where is this greater than 0? So let's say, okay, here, no. Here, on the y-axis, I'm at like minus 3 or something. Here, I'm greater than 0. Here, on the y-axis, I'm at like 10, I don't know. It's greater than 0 anyway, okay? Here, yes, positive here, up, positive. Here are positive numbers, here are negative numbers. So not here, but here and here. So my solutions are greater than 0 when x is greater than 7, not equal to 7. At exactly 7, you plug in 7, you get the answer 0. So it's not greater than 0. It's got to be more than 7 to give me an answer in this section where it's positive, where it's up in positive y values. Or it's got to be less than minus 1, because see down here, okay, all of these numbers here, all of these y coordinates are positive. They're all up positive y coordinates as opposed to negative y coordinates down here. So this answers the question, for what values of x is this function bigger than 0? Obviously, same question, but with less than or equal to 0, I'd be looking at this bit here. that would give me the solution. X has got to be sandwiched between -1 and 7. And see, it could be equal to 0. Then it could be equal to the limits. So this would answer the same question, but with less than or equal to 0 instead of positive. Okay, there we go.